Hi everyone. Today we are going to learn about some of the key properties and characteristics of kites. And if we want to understand those properties and characteristics, it makes sense for us to start with how can we draw a kite using other shapes we already know. The easiest way to do that is to start with some triangle. Now you notice that I specifically drew this triangle that is scalene, right? It is scalene, which means that all three sides are a different length. And what I am going to do is I'm going to reflect that triangle over this line right here. And I'm going to call that line A, just to help us out. When I reflect that triangle, we're going to look like this. Now, if we think back to what we learned about reflections last semester, we know that reflections maintain congruence. So this piece right here is going to be congruent to this piece over here. This piece is going to be congruent to this line right there. We know that the line of reflection will stay congruent. We know some angles are going to be congruent to each other. Those two angles, and then those angles as well. And we created a kite. A kite is a quadrilateral. So if we start listing some properties, we know that one, it's a quadrilateral. We also can see that these two sides are congruent and these two sides are congruent, which is a little bit different from what we talked about with parallelograms. In this case, I'm going to say that we have two pairs of consecutive congruent sides. If we think back to parallelograms, we had two pairs of opposite congruent sides because the sides were across from each other. Consecutive in this case means next to. We also see that it has one pair of congruent angles. And to help us differentiate it, we are going to call these two angles over here our vertex angles. Vertex angles are lie within the congruent sides. So whereas over here you see that these two sides are not congruent, so those angles between them are we're just going to call them our non-vertex angles. So we know that our non-vertex angles are congruent. Now let us also think about our vertex angles. If we notice, because we reflected that triangle, these two parts of that vertex angle are congruent. So we could say that our vertex angles are bisected by the diagonal. Once again, we call this line a diagonal because it goes from vertices that are not adjacent to each other, not next to each other. Our last characteristic, or I suppose our last two characteristics, is what happens when we draw our other diagonal. Well, what two triangles did we just create here? This triangle up here is isosceles, and this triangle is isosceles. We actually drew this first diagonal as the altitude of these two isosceles triangles. And we know that this is going to be perpendicular to the base. So we could actually say that both diagonals are perpendicular, and that is our symbol for perpendicular. And then the last thing that we can look at is this is an isosceles triangle. So this part of the base has actually been bisected. So we could say that the diagonal between the congruent angles is bisected. So now let's talk about a couple of things about how we can use this kite, because these are all of our properties. A lot of these should be familiar. The only difference is where they are in our shape compared to, say, a parallelogram. Well, if we look at our kite, I see 4 small triangles within my kite. Now, what do I know about those 4 small triangles? They all are right triangles. So we know that our kite makes 4 right triangles. If it makes 4 right triangles, we can use Pythagorean theorem. We could use special right triangles. We could use trig to find out more information about what's going on within our triangle or within our entire kite. It also helps us because we can calculate angles, and then we could reflect that figure over to know the angles on the other side. The last thing I want to talk about is, what about a special case? If I had a special case where the 2 pairs of sides are actually congruent to each other. So it might look like here's one pair of sides, and they are congruent. And then here's my other pair of sides, and they are also congruent. Well, what figure did we just create? We created a rhombus. We created a rhombus here because it now has 4 congruent sides. So for some mathematicians, they consider a rhombus to also be a special type of kite, in the same way that it is a special type of parallelogram. Now, this also could be a square if these were right angles. To make it clear, I could draw it like this. And that is definitely not a square, but it is a rhombus. So that is our special case of kites. Thank you guys, and now we're going to do some example problems in our next video.